Okay, in this video we're going to talk about u-substitution. Now u-substitution is a reversal of the chain rule. So let's recall the chain rule applied to a composition of functions where the outside function is a power function. We'll call this example 1. So let's differentiate x cubed plus 4 to the 10th power. Okay, so the chain rule says we bring down that power, we leave the inside alone, we subtract 1 from the power, and then we multiply by the derivative of the inside, which in this case is 3x squared. So in this video, we want to think about reversing this process. We want to antiderive this 10 x cubed plus 4 to the 9th power times 3x squared and get the original x cubed plus 4 to the 10th power. And so let's just write it out. So let's say the antiderivative of 10 x cubed plus 4 to the 9th power times 3x squared dx equals x cubed plus 4 to the 10th power. Now, if we stared at this for a while, if we started with this integral and we tried to figure out the antiderivative, it might take us a while to figure out that this is a chain rule situation. So what we want to do is we want to use u-substitution to kind of keep track of this and help us see more easily that this is a chain rule situation. So we're going to use this technique of u-substitution. So here's the first step. Step 1 is we want to call the inside function u. And then secondly, we're going to find du. We're going to differentiate this inside function to find du. We may need to adjust this slightly. And then we're going to substitute u and du for x and dx. Then we're going to antiderive this integral with respect to u. And then we'll back substitute x for u. Okay, so let's go through these steps. Let's move this over here and go through the steps. So first we're going to identify u. U is the inside. It's somewhat obvious that the inside here is this x cubed plus 4. It's being raised to the 9th power, so it's inside the x to the 9th function. And then we're going to take the derivative of this. So du dx is going to be 3x squared. Now I said find du, so we want to treat this du dx as a fraction, and we're going to multiply both sides by dx. And we'll get 3x squared dx. Okay, so now I have u, and I have du. And du is, if you look at it carefully, it's the right side of this indefinite integral. It's the 3x squared times dx. And now I can substitute u and du for x and dx. I'll get 10 u to the 9th du. And this is an easy function to antiderive with respect to u. The antiderivative of u to the 9 is u to the 10 over 10. We include the coefficient 10 and we include the plus c. Those 10's cancel, we'll just be left with u to the 10 plus c. And now we're to our last step where we back substitute x for du. So remember our u is x cubed plus 4. Let's put it in, x cubed plus 4 to the 10th and plus c, and we have our antiderivative. And this fits with what we started with in the beginning of this problem. All right, let's do another example. Okay, so in this example, we're going to right off the bat find our u. Our u is x squared plus 2. And we're going to find our du. So you could write du dx equals 2x and then multiply both sides by dx. But I'm just going to jump right to the differential. I'm going to say du is 2x dx. Okay? And now we can substitute u and du for our x and our dx. So we get u to the 11th, and now we've run into a problem. So you can see that we don't have 2x dx, we just have x dx. So if we go back to our rule here, we said we're going to find du, and it also says we may need to adjust this du. So let's go over here. We have an x dx, and we're going to now adjust the du equals 2x dx equation so that it matches what's left over after our u substitution. So what I'm going to do is I'm going to multiply both sides of this equation by 1/2, and I'll get 1/2 du equals x dx. And now I can substitute x dx for 1/2 du. Now that 1/2 is just a coefficient, so I can write this like 1/2 the antiderivative or integral of u to the 11, and the integral of u to the 11 is u to the 12 over 12. Include the 1/2 and include a plus c, and then we back substitute our x squared plus 2 for u, and we have our answer. And I'm going to rewrite this as x squared plus 2 to the 12th power all over 24. 2 times 12 is 24 plus c. Now you can check your work here by differentiating this function and seeing that you get the original x squared plus 2 to the 11th power times x. All right, let's do one more example. All right, so let's start by defining our u. Our u is going to be the inside, this 3x squared plus 6x, and our du is going to be 6x plus 6 dx. Again, you can see that this substitutes nicely in the bottom, but the numerator isn't quite what our du is here. Our du is 6x plus 6 dx, and the numerator in the original is just x plus 1. If you look carefully at this, you can see that the 6 factors out. And then we can divide by that 6, or multiply by 1/6, and we'll get 1/6 du is x plus 1 dx. And that's exactly what's left over here. So then I'll get 1/6 du in the place of x plus 1 dx. That 1/6 is just a coefficient. I'm going to bring it out front, and I'm going to rewrite that 1 over the square root of u as u to the negative 1/2. Then I can use the power rule, the reverse power rule, and I'll get 1/6 u to the negative 1/2 plus 1 all over negative 1/2 plus 1 plus c, which I can rewrite as u to the positive 1/2 over 1/2 plus c times the 6. And then flipping that 1/2, so dividing by half is the same as multiplying by the reciprocal of 1/2, or flipping 1/2, and I'll get 2 times 1/6 u to the 1/2 plus c, which is 1/3 u to the 1/2 plus c. And then u, we're going to back substitute our x for u, and we'll get 1/3 3x squared plus 6x to the 1/2 plus c. And it might be a good idea at this point to differentiate this answer and see that we get our original integrand, our original function. So let's do that really quick. Let's take the derivative of our answer using the chain rule. If we differentiate the 1/2 power, we get a 1/2 coming down, 3x squared plus 6x to the negative 1/2. And then all times the derivative of the inside, which is 6x plus 6. The plus c becomes 0. And then simplifying, we get 1/6 3x squared plus 6x to the negative 1/2, all times 6x plus 6. The 1/6 hits the 6x plus 6, and we're left with just x plus 1. And the negative 1/2 can be written as positive 1/2 in the denominator, like so. And then that 1/2 power can be written as a square root. And we have our original function, x plus 1 over the square root of 3x squared plus 6x. So our antiderivative looks like it's correct. All right, I hope you found this video useful.